Hello everyone, welcome to the Masti Virtual. Hope you are doing well. Today I'm going to continue with chapter number 2, that is formulating and manipulating the representation of information. This is chapter number 2. Just a minute. The chapter name is representing and manipulating the information. Till now we have covered 2 topics of this chapter. Now I'm going to continue with third topic. In the last class we have talked about some programming concepts. So let's quickly refresh all the programming concepts. In the last class we discussed what is the programming, how we can do the programming. What is the programming? Programming is nothing but a series of instructions. Then we have also talked about how a code of a program is written and how it will be executed. We have also talked about some programming languages like Java, C++, .NET, and we also talked about some JavaScript that are interpreted and occupied by the system. Then we also talked about a set of commands that a computer uses to understand. There are some multiple commands, other languages such as high-level languages to print the hello. Then we have talked about some examples of programming like logo that is used by the programmers, JavaScript, Fortran, Basic, COBOL, C++, Pascal, assembly language. Then we also talked about how to write the programs. There are multiple methods. One of the methods is pseudocode, flowchart, and how we can translate into the programming language. So these are the multiple steps. Pseudocode is written in the English statement and flowchart are represented by the graphic symbols. After representing or after converting or after writing in English statement or languages or symbols, then a programmer converts into the programming language like C, C++, Java, .NET, and then at last try to find out debug the program, means try to find out the errors in the program. So these are the multiple steps how we can write the program. Then we also talked about what is pseudocode. Symbol that is written in English is known as pseudocode. This is the example for pseudocode. This is the question, means addition of 2 numbers. This is how what does a flowchart look like? This is a flowchart. We can use by representing the symbols. There are multiple symbols that are used like start and input output process, decision. Then we have also talked about some symbols like start and input output process, decision, pseudocode. This is another example for calculating the age that is done by the pseudocode. Then we also talked about a flowchart with the same example, means of calculating the age. And there is also a decision box. This is the decision box. Then we have talked about what are the elements of a program like variables, commands, loops, decisions, functions. Variables are nothing but a place of data or place of where we can put the data. This is a variable. How we can store the data? By using the equals to sign. There are 2 types of variables. One is local and one is global. This is a global variable. This is a local variable. Then we have talked about a loop. What is a loop? That is continuing in program that is known as loop. It says it is a repetition of all or part of the commands in a program. Then we have talked about what is a decision, how we can represent the decision with the help of flowchart. This is the decision like if-else statement. What are the functions in programming language? Functions are nothing but the sub-programs or the small program that is used to perform one of the specified tasks given by the programmers. Example, get name, calculate x. Then we also talked about what a function do. What are the repetitive statements that is available in any programming language? There are three kinds of repetitive statements. One is while loop, do loop, and for loop. This is the syntax for while loop. Example. This is the logic of a while loop. Then this is the example of a while loop. Then there are multiple infinite loop also. This is the example of infinite loop. There is also a nested loop, means loop within the loop, that is known as nested loop. This is the example of nested loop. This is another example or another looping is do while statement. This is the syntax for do while. This is the logic for do while. And next slide shows example of do while. Then we have also talked about the comparison between while and do while. While is the entry control loop and do while is the exit control loop. In while we check the condition at the starting phase, but in do while we check the condition at the ending phase or at the exit phase. Another loop is for statement. In this we can give everything like condition, initialization, but only one line, and these multiple parts are separated by the semicolon. One is initialization, condition, increment, then statement. It may be increment or decrement. This is the logic for a for loop. This is the example for for loop or syntax. This is the example. Then hints for writing the code. Then at last we talked about what is debugging. And there are multiple questions. There are multiple examples which we have to do. This is what we covered in the last class. Now today I am going to continue with your main module, that is chapter number 2, and the topic is integer arithmetic. Till now we have covered two topics and the chapter name is representing and manipulating the information. Now the next topic is integer arithmetic. As the name advises, integer arithmetic means how we can perform the operations on the integer. Arithmetic means performing the operations like plus, minus, divide, multiply, addition, subtraction, division, multiplication. So binary integer arithmetic is nothing but the operations on the integer value. This is many programmers, beginning programmers, are surprised to find that adding two positive numbers can yield a negative result. Can you imagine? Whenever we add two positive numbers, they can also, or they may be also, gives a negative result, and that the comparison x is less than y can give a result then the comparison x minus y is greater than 0. These properties are artifacts of the finite nature of computer arithmetic. Understanding the nuances of computer arithmetic can help programmers write more reliable code. So we have to understand these concepts, these arithmetic, so that we can understand the programs very well in C language. So now let's see with the help of PPTs. This is arithmetic without fractions, means arithmetic is nothing but integer arithmetic is nothing but the arithmetic without any fraction, means there is no decimal place, only the integer value counts. Next is a computer performing integer arithmetic ignores any fraction that are divided. Suppose I am adding two numbers and by chance suppose a decimal number arrives. So integer arithmetic discard or avoid or ignore that integer or that fraction part. Right? For example, 8 when divided by 3 would yield the whole number 2. So whenever I divide 8 by 3, so 8 into 2 is 6, so the remainder is 2. But the output is 2 only, that is the whole number, so that is the integer arithmetic. Means in simple terms, whenever we add or whenever we perform any operations on the values, and if only discrete value or the positive value or any without decimal comes, that is known as integer arithmetic. Now next is how to add the unsigned number. This is the next topic. 3.1 is unsigned addition. So how to add the unsigned number, adding unsigned numbers. As I told you, there are two types of number, unsigned and signed numbers. This says introduction, adding numbers in binary is pretty much the same as adding in base 10. As I told you, there are four types of number system: binary, octal, decimal and hexadecimal. This says adding numbers in binary is pretty much the same as adding in the base 10. Base 10 means that is a decimal number. In fact, you could argue that it is even easier. Means it is even easier to add unsigned number than the base 10. Suppose you want to add two UB. UB means a bits, that is a 4-bit number, x1, x3, x2, x1, x0 and y3, y2, y. You want to add these two numbers together. Here, pseudocode to add the two numbers. This is int carry, this is a C program. Understand? Means first of all, initializing the variable, that is carry contains the value 0. Then there is a for statement or for loop. One is initialization, that is I also contain the value 0. The condition is that till when the n is less than or n is greater than I, till the condition is true. Then there is a I++. Then there is a curly braces. Then next one is int sum, means a variable declaration, that is int sum equals to xi plus yi plus carry. Xi means x base 0 because the I value is 0. Yi means y0 plus carry. Carry contains 0 value. This adds the value, that is x0 and y0 in the first iteration. Then next says zi, means z base 0 equals to sum divided by, this is a modulus operator, this gives the remainder, sum modulus 2. Next, if sum is greater than equals to 2, carry equals to 1. If sum, that is the output is greater than or equals to 2, then the carry is equals to 1. That means we can extend the loop, we can increase the loop and going to the further. Then in the next iteration, I becomes 1 and 1 is less than equals to 9 n, that is the n value. The condition is true. Now I is 1, so it will add x1 y1 plus carry, that is your 1 if x sum is greater than equals to 2. This is how we can add in unsigned number in C language. This is an example of C language, but in simple terms we can add the number very easily. This is how we can add the number. This is an example. This says let's add 11012 to 1101. Assume both are 4-bit UB numbers. Let the rightmost column to be column 0 and the leftmost column to be column 3. So first of all, add the rightmost column, that is column 0. This is 1101, 1101. Summing up, 1 plus 1 is in a result 0 with the carry of 1 to the column 1. And I told you in previous class, that last class, how to add 1 plus 1. Yes, in addition. So this is how we can add the unsigned number. Summing 1 plus 1 results in 0 with the carry of 1 to the column 1. So this is column 0, this is 1, this is 2 and this is 3. This says if I add 1 plus 1, that is the output 2 and out 2 has a binary number 0 and 1. So 0 comes in column 1 and 1 comes in column 2. So this is 0 and this is a carry. Then add the 2 bits in column 1. This is the column 1, add 2 bits, means this one and this one. Plus the carry bit. This plus the carry bits. Summing 0 plus 0 plus the carry 1 results in 1. So this is 0 plus 0, 0. 0 plus 1 is 1 with the carry of 0 to column 2. Because there is no carry, that is forward to column 2. This is 1. This is how we can add the number. So this is the first step, that is column 0. This is the second step, that is column 2. This is the next step, 0, 1. There is no carry, so this goes to the 0. I think this is clear to you, Nelda. Then next one is now add the two bits in.
Hello?
Yeah.
Hello?
Yeah.
Maybe you can just go over it again. I got distracted a bit.
Okay, okay.
Yeah.
Now then add the two bits in column 2. This is column 2. Now add the two bits. This is column 2. Plus the carry bit. Carry is now 0. So add 1 plus 1, that is 2. That have a value 0 over here. 1 is the carry. 0 has a no value. So 1 plus 0 is only 2. So 2 has a value 0, 1. So put over here 0 and put the carry over here 1. This is summing 1 plus 1 plus the carry 0 results in a 0 with a carry of 1 to the column 3. As I told you, this is 0, 1, this is 0 and the carry is 1. Now finally add the two bits in column 3. This is column 3. This is 1 plus 1 is 2 plus the carry bit. Summing 1 plus 1 plus carry 1 results in a 1 with a carry of 1 to column 4. Because 1 plus 1, that is 2, that have a output 0. Remember, first of all add these two numbers. 1 plus 1 is 2, that have a output is 0. Now add 0 plus 1, that is your 1. So this gives a 1 plus the remainder 1 with that. Alright. With a carry of 1 to column 4. This is the column 4. We have to create a column 4 to place the fifth bit of the result. So this is column 4. This is how we can calculate the number. Now let's take another example. Suppose I have to add 1010 or no, this is not correct. 1100, then 1111. Yeah. Suppose I want to add these two numbers. So first one is 0 plus 1 is 0. 0 plus 1 is 0. Means there is no remainder, that is 0, and there is a output 1. Now next is 1 plus 1, that is 1 plus 1 is 2. So put over here 0 and put over here 1. This is the remainder. And here, this is the carry. Here there is no carry, so this is 0. So 1 plus 1 is 2, so it has a 0 value and the carry is 1. Now add first of all these two numbers. 1 plus 1 is 2, it has a value 0. So consider 0 and then add to the 1. I am repeating again. First of all, consider these two values, that is 1, 1, that have a value 0. Now add 0 plus carry, that is your 1. But whenever I put 0 over here, so remainder goes to the next column, so put over here remainder. Now 0 plus 1 is 1 and the remainder and the carry is 1. This is the carry. I am repeating again. Whenever I add 1 plus 1, that I have a value 0, so put over here 0. Then add 0 to the carry, because carry is also available. 0 plus 1 is 1. But whenever we add 1 plus 1, put 0. So 1 carry is also left, that is going to the next column. This is 1, 1, 0, 1, 1. This is the output. So this is the procedure how we can add three numbers. First of all, use two numbers, use 0, then add the remainder and the carry, and then forward 1 to the next column. Alright. This is the same example. Here 3 1s. So this is how we can add the numbers and put the carry to the next column. That is the next bit. Now next is the most important slide. Since we add in hardware, the output usually has the same number of bits. This is the most important slide. Suppose I have to add 4 bits, so the output must be in the 4 bits. Suppose I am adding only 3 bits, so output must be in 3 bits. So whatever the bits of the question, that is the output of the or the answer of the question. Means suppose I am using 2 bits, so the answer is in 2 bits. I am using 5 bits, answer is in 5 bits. This is, since we are using the hardware, the output usually has the same number of bits as the number of bits being added. Since we are adding 2 bits UV number, the result could give a 4-bit result. So, but the main thing is that here the result is 5 bits. So, I am using only 4 bits, that is 1010. So, discard that leftmost bit. Means whenever I have to discard the bits, so only discard the leftmost bit. So, the output is 1010. I think this is clear to you. I'm repeating again. I have to add two numbers. This is the unsigned addition, that is 11012 110. So I put 1101 1101. First of all, divide these into the multiple columns. This is column 0, column 1, column 2 and column 3. So first of all, add these two numbers, put 0 and this is the carry. Then in next step, 1 plus 0 is 1. There is no carry, so put 0. Now 1 plus 1 is 2. Put 0. This is 0 and 1 is carry. So carry is provided to the next column. Now this is 1 plus 1, that is 2. Use 0 and put over here carry to the next column. Now 0 plus 1 is 1. So this is 1. So the output is 11010. But we are using only 4 numbers for addition. So I have to use 1010 only 4 numbers. This is how we can add the unsigned numbers. So this is the unsigned addition. Now let's see in the book what is said. No, we have to discard the value because we have to add only 4 bits. So there is no reason for discarding the value. The only reason is that we have to use only 4 bits for addition. So discarding the value is the most significant method because I am discarding only the left bit. So there is no difference in the output. This says unsigned addition, consider two non-negative values such as this one, this one. Each of these number can be represented by the W-bit unsigned numbers. This says whenever we have to add two numbers, we use the unsigned addition. This is the integer addition. Today there is network problem, so I'm so sorry for this. This will be add. So this is how we can add the unsigned numbers. These are the examples of adding the unsigned number. You have to practice this. And this is next problem, that is write a function with the following prototype. This is the C syntax. I am using C syntax, that is int you add OK unsigned x unsigned y, because I am using unsigned number. So I have to specify the range. I have to specify the data type, that is unsigned x or unsigned y. You add means you addition of two numbers, that is you add unsigned addition or and OK. So this is how we can add the unsigned numbers. Now let's start with next topic, that is unsigned multiplication. As I told you, how we can add the two numbers, how we can add two unsigned number. In the same way, we can add the two unsigned multiplication. Or we can multiply two unsigned numbers. How we can add? Simply use 1 plus 1 is 0 and put the carry forward, that is to the next column, and again 1 plus 1 carry of 0 and the put carry to the next column. In the same way, we can multiply the two unsigned number. Now let's see how we can multiply. This is unsigned multiplication method. This is paper and pencil example. First of all, we have to use the multiplicand, that is 1000, and there is a multiplier, that is your 1001. So I have to multiply these two numbers, that is 1000 and 1001. So first of all, use 1 into this, that is your 1000. Then use 0, that is 000. Then use another 0, that is 000. Then use 1, that is your 1000. So the product is 01001000. This is 01001000. How it is calculated? First of all, use 1000. That is your first hand bits, 1000. Then 0100. This says binary makes it easy. Place 0 by or place 0 by multiplicand. 1 place a copy, that is 1 by multiplicand. That is, we have to multiply 0 by the multiplicand and 1 by the multiplicand. Next example is how we can calculate. First of all, whenever we have to multiply two unsigned number, that is 4 bit, that is 8 and 9. So 8 have a binary number 1000, 9 have a binary number 1000. So I have to multiply these two numbers. So first of all, use 1 addition 000 So whenever we add these numbers, whenever we add all the numbers, so the output is 1000. Right. This is the 1000. Whenever we add, this is the product, that is 1000. This is how we can multiply the numbers. This is a topic how we can add. Simply you have to note down this formula. This is x into u by, this is the main formula, x into u w by equals to x into y mod 2 by w. Simply you have to remember this formula, nothing else. Now next topic is how we can use the 2's complement multiplication. This is one of the important topic, how we can multiply 2's complement numbers. This is again the formula, x into, this is the x into w, uw, this is x into tw, y equals to u2 tw xy mod 2w. Means we have to find first of all mod and then multiply by 2w. 2 by w numbers. This is the unsigned number, that is 5. This is the 2's complement. This is the 357. These are the multiple examples. I have to tell you the examples. This is the how we can use the 2's complement multiplication. This says in 2's complement, to always get the right answer without thinking about the problem, sign extend both integers to twice as many bits. Means you have to sign extend both the integers as many bits twice whatever you want. Then take the current number of result bits from the least significant portion of the result. A 4-bit, 2's complement example. This is the example. This is 1111 1111 1111 1011. This is the -1 value. This is the -7. So I have to multiply 2's complement, means a 1 value by minus 7. So the output is, as you know, 7. Now let's see what is the output. First of all, use 1, then multiply all the numbers. Whenever I use 1, this is 4 times 1, 4 times 1, that is your 8 times 1. Then use 0, so the 8 times 0. Then use another 0, that is 8 times 0. Then use 1, this is 8 times 1. Another one, that is your 8 times 1. Another one, that is 8 times 1, and so on. So whenever we add these numbers, so this is the addition. First of all, use these two bits, means first of all use these two numbers, then use the output that is come from these two numbers, then add these numbers or these bits, then add these bits. So this is a so lengthy process. So I have to add first of all 2 bits, means the pair of 2 bits, that is 8 bits. Then output is added to another bit, then that output is added to another bits, another bits, another bit, and finally the output arrives. This is 0, 0, 0, 0, 0, 0, 0, 0, 1, and this is the discarded value. That is your correct answer. Now let's see with the help of example. First of all, how we can add unsigned multiplication and how we can add two signed multiplication. Suppose I have to multiply these numbers. Okay, I have to multiply these numbers. So first step is, first of all, you use number. So whenever I multiply 0 by all the bits, so the output is 0, 0, 0. Then this is 1, so this is 1, 0, 1. Then again 1, so this is again 1, 0, 1. Now, so sorry, this is 1. Now I have to add these numbers. So first of all, I am using these bits. So first of all, I am adding only these two bits, that is 0, 0, 0 and 1, 0, 1. This is output is same, 1, 0, 1. Now use these 3 bits to add this number. This is again 1, 0, 1. So this is what the final output comes. This is 1 plus 1, that is 0, and the carry is 1, and the output is 1. 1 plus 1 is 0, output is carry is 1. So I have to discard this carry because we have to add 3 bits only. So the output or multiplication is only 0, 1, 0. This is how we can add or how we can multiply unsigned numbers. I am repeating again. Suppose my example is I have to multiply 101 with 110. So first of all use 0 and multiply by 0. This is 000. Then use 1, multiply by all the bits 101. Use 1, multiply all the bits 101. Now next step is add all the 3 bits, all the grouping of 3 bits. First of all use a grouping of 2 bits only, that is 000 is added to 101. So the output is, this is addition, output is 101. That output is added to another group of bits, that is 101. So the output is 1010. As I have to use 3 bits only, so I have to discard the leftmost bit, that is 1. So the output is 010. This is how we can multiply unsigned numbers. Let's take another example. Suppose there are 4 numbers 1011, 00, 00, 10, 00. Suppose I have to multiply these numbers, like, so first of all use 0, because these are the 4 zeros. Then use another 0, these are the 4 zeros. Then use another 0, that is these zeros. Then use another 0. No, this is 1, so this is 0, 1, 0, 1. Now I have to add all these numbers. So I have to add these numbers. So this is 0, this is 0, this is 0, this is 0, this is 1, this is 0, and this is 1. right? But I have to use only 4 bits. These are the 4 bits, so I have to use only these 4 bits. I have to discard all the bits. So the output is 0, 0, 0, 0. This is how we can multiply two unsigned numbers. Now, next is what is the step for calculating the 2's complement multiplication. In the same way, but the main difference is that now the numbers is in negative terms. Suppose I have to multiply 2 with 4. So first of all convert 2 into binary. This is 0, 0, 0, 1. Now I have to convert into 4 bits. This is 0, 0, 1, 0. I have to give the leading zeros. Now next is converting 4 into bits. This is 2, 2, 0, 2, 1, 0, 2, 0, 1. I have to convert into 4 bits, so this is 0, 1, 0, 0. Now I have to multiply these two numbers 0, 1, 0, 0 into 0. Same procedure as it is. I use 0, 0, 0, use 0, 0, 0, then 1, then 0, and then add the numbers. Now if the question comes, then I have to multiply -1 into -2. So in simple terms, first of all convert 1 into binary, 2 into binary, without seeing the negative sign, multiply the bits into the bits, and then at last output arrives, that is your only 3. This is how we can calculate the 2's complement multiplication and how we can calculate multiplication of two unsigned numbers. Now, next topic is yours. These are the multiple problems, these are the syntax, or these are the example in C language. Now, next topic is dividing by power of 2. As the name advice, whenever we divide the number of with any number by power of 2, as I told you, 2 power 0 into 1, 2 power 1 into 0. This is how we can divide by power of 2. This says integer division on most machines is even slower than integer multiplication, requiring 30 or more clock cycles. Dividing by power of 2 can also be performed using shift operation. Means whenever we divide by power of 2, it can also be performed using shift operations in computer architecture. But we use a right shift rather than a left shift. The two different shifts, that is logical and arithmetic, serve this purpose for unsigned and 2's complement number respectively. These are the multiple examples. These are the for x is greater than 0, y is greater than 0. This is the example. Now, this is the main point. We have to right shift the numbers. This is 1, 2, 3, 4, 1, 2, 3, 4, 0. This is the binary conversion. And this is whenever we divide any number by 2 power 0 or 2 power by power of 2, that is 2 power k. This is right shift by k digits. So this is the decimal number, this is the binary number. K equals to 1, this is the decimal number, this is the binary number. This is the decimal, this is the binary, this is the decimal, this is the binary. This is applying arithmetic right shift. This example illustrates that arithmetic right shift is similar to division by power of 2, except that it rounds down rather than towards 0. This is how we can calculate or how we can perform the right operation or right shift operation on whenever we divide by 2 power k. This is another example. This is the binary number, this is the right shift, this is the decimal number, and this is the dividing by power of 2. Now, this is the next example in C language. This is hash define M. Hash define M means M is already defined in the computer, that is hash define M. Means whenever we have to use M in the computer system, M in the coding part, so I have to use them in simple terms. Whenever we have to add or whenever we have to use any characters, any variable, so I have to define it at the top by using the header file, that is hash define M. Hash define M. Next is your function. This is int arithmetic. This is the function name. This is the data type. I have to use arithmetic, and that data type is int. There are two variables, that is int x and int y. Then there is a variable declaration, that is int result equals to 0. Now calculate result equals to x into m. X is the variable which is given by the user. So multiply that value by m, as m is defined already at the top. So that value, m value, is multiplied by the whatever the user inputs, and divide the y value by m. So these are the values that is required by the user, that is already defined, and then at last return the result. This code is used, how we can use the defined, or how we can define the variables in the header files. This is the next example. This is the right shift example, left shift example. Now the next topic is final thoughts on integer arithmetic. And this is a wind up of this topic, that is third topic, that is final thought on integer arithmetic. This says, now let's see line by line, because this is the final thought. As we have seen, the integer arithmetic performed by computers is really a form of modular arithmetic. As I told you, integer arithmetic that is performed by the computer is really a form of modular arithmetic. The finite word size that is used to represent number limit, the range of possible values, and the resulting operations can overflow. As I told you, whenever we add or whenever we multiply numbers, there are so many numbers which are overflow, that could be discarded by the left hand side. We have also seen that the 2's complement representation provides a clever way to be able to represent both negative and positive numbers. So this is the best example for using the 2's complement. As I told you, whenever we use 2's complement, addition or multiplication, so the main target is there are negative numbers available, so I have to convert that negative number into the arithmetic forms, that is operations such as addition, subtraction, multiplication. So there is a provision that I am using to complement addition, subtraction, or even multiplication, division, that have identical or very similar bit level behaviors, whether the operands are in unsigned or 2's complement form. We have seen that some of the convention in C language can yield some surprising results, and these can be sources of bugs. These are the errors that are hard to recognize and understand. This says whenever we use these comparisons, whenever we use these complements like 2's complement, addition of 2's numbers, unsigned integers, unsigned multiplication, this gives us bugs in the C language, lots of bugs in the C language that is very difficult to understand and recognize. So we have used only the unsigned data type. This is said, we have especially seen that the unsigned data type, while conceptually straightforward, can lead to behavior that have experienced programmers do not expect. So we have also seen that this data type can arise in unexpected ways. So whenever we use unsigned integers or unsigned data type, this gives an error in some way to the programmers. For example, when writing integer constant and when invoking library routines, this is I think finished. Yeah. This is very expected ways, unexpected ways. For example, when writing integer constant and when invoking library routines. So this is the limitation for using the unsigned number whenever we use the integer constant and whenever we invoke library routines. This is the example. Assume we are running code on a 32-bit machine using 2's complement arithmetic. For signed values. Right shifts are performed arithmetically for signed values and logically for unsigned values. The variables are declared and initialized as follows. This is how we can declare the variable. This is int x equal to foo, int y equals to bar, unsigned ux equals to x, unsigned uy equals to y. For each of the following, see expressions. Either one is argued that it is true for all values or give values to of x and y for which it is false. This is x is greater than 0 or x minus 1 is less than 1. So suppose I am using values 1. So 1 is greater than 0, output is true. 1 minus 1 is less than 0, output is false. This is the AND operator. So in AND operator, if any one of the condition is true, then the output is true. So in this case, first one condition is true, but second one is false, even though the output is 1, because output is true. Because in or any of the condition is true, then the output is true. Then next is x and 7 is not equals to 7, or x whenever we write shift by 29 is greater than or less than 0. So if this is true and this is true, then even the output is true. If one of the condition is true, then the output is also true, because there is a AND operation in between. In the same way, you have to attempt all the questions. This is the question: x plus y double equals to. Double equals to means we have to compare the value. So if there are two values, that is x or y. For example, x has a value 10, y has a value 20, u has a value 10. So this is 20 plus 10 is 30. This is 10 into 10 is, this is 10 into 20 is 200, plus 10 into 10 is 100. So 200 plus 100 is 300. That is not equals to 30. So this is a wrong situation. The output is false, because this is the equality sign that is used for calculating or comparing between two variables. Even in the same way, you have to attempt all the questions. Now next is floating point. This I have to discuss in the next class, that is tomorrow's class. Yes, sure, Nelda. Multiplication and division examples. Yes, sure. Now let's see some examples of multiplication and divisions. First of all, take the examples of addition. Suppose I have to add these two numbers. 10111 plus 0011101, right? So 1 plus 1 is 0 and the carry is 1. Now I have to add first of all these two bits. 0 plus 1 is 1. 1 plus 1. Now use carry. 1 plus 1 is 0. Again put carry. Here 3 1 comes. This is the main situation where 3 comes. But first of all, calculate this one. 0 plus 1 plus 1 is 0. Carry is 1. Right. But this 0 is again added to the carry. So the output is 4. So this is not the output. Output is 1. I am repeating again. First of all, 1 plus 1 is 0. 1 is carry. 1 plus 1 is 0. 1 is carry. Now 3 ones comes. First of all, use these two numbers. Lower two ones. 1 plus 1 is 0. But there is also a 1. So 0 plus 1 is 1. But the carry goes to the 1. In the same way, you use first of all these two bits. 1 plus 1 is 0. 0 plus 1 is 1. But the carry is 1. Now 1 plus 1, 0 is 0. 0 plus 0 is, or 1 plus 0 is 1. There is no carry. So carry is 0. Now 1 plus 0 is 1. So this is the output. Here we have covered only 6 digits. So this is 1, 2, 3, 4, 5, 6. This is 1, 2, 3, 4, 5, 6. So there is no discarded digit. So this is the output 1, 1, 1, 0, 0, 0. This is how we can calculate the addition part. Let's take one more example. Suppose I have to add these numbers. Right. This is 1, 1, 1, 1, 1. So first of all, this is 0, this is 1. 1 plus 1 is 0, 0 plus 1 is 1, and the carry is also always 1. Again, 1 plus 1 is 0, 0 plus 1 is 1, carry is 1. Again, 1 plus 0 is 1, 1 plus 1 is 0, carry is only 1. Again, 3 zeros, 1 plus 1 is 0, 0 plus 1 is 1, and the carry is carry is 1. This is the output, but we are using only 5 bits, so I have to discard this 1. So the output is 1, 0, 1, 1, 0. This is how we can calculate the addition part. Any more examples, Nelta, for addition? Okay. Basically, subtraction is your next topic. So I have to discuss in either Tuesday's class or Wednesday class of subtraction. Today's topic is only on addition and subtraction. Addition, multiplication, and only addition, multiplication. Subtraction and division is in the next class. Okay, multiplication. Suppose I have to multiply these numbers, that is 1011 with 1111, right? So first of all, use 1 using all this. So this is same. Again 1011, again 1011, again 1011. So this is 4 bits: 1011, 1011, 1011, and 1011. Now I have to add these 4 bits. So first of all, take these 2 bits. Right. So whenever we add these 2 bits, 1 plus 1 is 0, remainder is, carry is 1. 1 plus 1 is 0, 0 plus 1 is 1, but the remaining carry is 1. Here only 1, again 0 and 1. So this is 0 and 1 is discarded. Right. Now I have to use these bits for adding with this one. So now I have to add 1011 with 1011. Here 1, this is 0, this is carry 1. Here 1 plus 1 is 0, carry is 1. Again 1 plus 0 is 1, 1 plus 1 is 0, and the carry is 1. I have to discard this one. So the output is 1, 0, 0, 0, 1. Now I have to add these with this digit. This is 1, 0, 1, 1. So in simple terms, use 2 bits, output is added to next bits, then another output is added to another bit. Now output is 0 and the carry is 1. This is also 0, carry is 1, this is 1, and this is 1. So the output is 1, 1, 0, 0. This is the output for this multiplication. This is how we can multiply the number. In simple terms, first of all multiply this one, use this one, and then add the bits. How we can add? First of all take 2, 1, and then output is added to this one, here output is added to this one. So this is how we can calculate the multiplication. Subtraction and division is also simple, but that is a part of next chapter. I think so. I'm not sure. But in Tuesday or Wednesday, I will discuss. If there is no topic in the book, I have to discuss with you. Please remember with me or remember me. Yes, multiply and then step-by-step addition. First of all, multiply that and then step-by-step addition. Any other doubts? Okay. Please Nelta practice it because there are so many questions. You have to make your own questions, and if you have practiced, then it is clear in your mind. Otherwise, it is not. So please practice hard. It's a tough time for you. I think so. So now let's recap what we have covered in today's class. Yeah, very tough, but you have to practice hard. All right. Now let's take a quick recap what we have covered in the today's class. We have started with integer arithmetic, means how we can add, how we can multiply the numbers, that is arithmetic numbers, that is integer numbers, that is without fraction. Then we have covered how we can add two unsigned numbers. This is the syntax, or this is the example in the C language. This is the example. This is known as column 0, column 1, column 2 and column 3. This is the best example how we can add these numbers. The main thing is that we have to discard the last digit if there are more than digits that we use for addition. Suppose I am using 4 bits for addition, then the output must be in 4 bits, not more than 4 bits. If there are 5 bits, then we have to discard the leftmost bit. This is what we have said. This is the 2's complement addition. So the next topic is how we can add the 2's complement addition. This is the 2's complement. In simple terms, I have to add with the negative values. So in simple terms, I have to use 56, first of all convert it into the binary, and then 19. 19 is in negative. So find out the 19 or find out the 2's complement for 19. How we can find out the 2's complement? First of all, inverting the bits, or first of all use the 1's complement, that is inversion of bits, that is converting the zeros into the ones and ones into the zeros, and then add the 1 to the inverting bits or 1 to the 1 bits. I am repeating again how to calculate 2's complement. First of all, find out the 1's complement. How we can calculate the 1's complement? Simply reverting the bits and then add to the reverting bits. This is how we can calculate the 19 2's complement, and then use 56, that is 0111 000 with 001001. This is how we can calculate the 2's complement addition. So remember, whenever there is a negative value, I have to use 2's complement addition. Now next is 2's complement negation. In the same way, we can also use the 2's complement negation. This is x bar 111, x plus x bar equals to -1. This is the syntax, this is the equation. You have to mark up this equation. This is how we can give the 2's complement negation. If there is a 3, then output is -3. If there is a -3, then the output is 310. Next, we have also studied how we can multiply unsigned multiplication. So this is the method. First of all, multiply and then add step by step. This is the method. Next is 2's complement multiplication. In the same way, we add 2's complement number. In the same way, we can multiply 2's complement multiplication. This is the example. So that's all for today's session. In the tomorrow's class, we will start it with floating point. Till now we have covered integer arithmetic. Now we will start with floating point, that is with the decimal numbers. So if you have any doubts, then please text the doubts. And thanks all for today's session. Tomorrow we will starting with floating point topic. All right. So all right. Bye bye. And if you have any doubts, then please text the doubts.